potential energy is stored energy. Potential energy is the energy stored in an object that can be used later as regular energy. In other words, potential energy can be converted into kinetic energy. And until it's converted, it stays stored in the object. A particular kind of potential energy that we're studying this course is gravitational potential energy. Gravitational potential energy is when an object has the potential to fall under the influence of gravity. The more height an object has off the ground, the more gravitational potential energy it also has. So the higher an object is, the more gravitational potential energy it has. The formula for gravitational potential energy looks like this. EP equals mgh, where EP is gravitational potential energy. And like all energy, this is measured in joules, given by a J. M in physics is always mass. If it's in a formula, then it's mass. If it's next to a number, it's meters. But since this is in a formula, the M is for mass, and mass is always measured in kilograms. We'll skip the G for a minute because I want to tell you the height is h. Height is a type of distance, so it's given in meters. So we have m for mass, h for height. This little g is a constant. A constant is any part of a formula that always has the same value no matter what. So this is the gravitational constant, where we're just going to refer to it as gravity. And Earth's little g, or Earth's gravity, is 9.81. So we will always put a 9.81 in the place of g in the case that we're on the Earth. If we're on another planet, then we have to put a different number in. Example. How much potential energy does a 5.25 kilogram rock have when it is held 2.30 meters above the ground? Just like in kinetic energy, to solve word problems, we follow the LURS method. We start by finding all the numbers in the question, and we find the thing that's being looked for, and then we list. The list step has M is 5.25 kilograms, H is 2.30 meters, And G we always know, so you can always assume that you know G, even if it's not told to you in the question. It's always there. It's 9.81. EP is our question mark. Then we pick a formula that has all of these things on our list in it. That's EP equals MGH. So far in LERS, we've done the L and the E. We've listed and picked an equation. We don't have to rearrange it. It's already in the shape that we need, so we can skip the R step. We can then substitute in our numbers. Plug it into our calculator. That's solving to get 118.46 joules. And then we finish with significant digits. Since the numbers we started with all have 3 significant digits, our answer must have 3 significant digits. So we cross out the last 2. We have 118 joules. Here's another example where we actually will have to rearrange. What is the mass of an object suspended 1.5 kilometers from the ground if it has 250 joules of potential energy? The numbers we are given is 1.5 kilometers, 250 joules, and we want to find what is the mass. So H is 1.5 kilometers. EP is 250 joules. We always know G, so you can always just write that down in your list. And M equals question mark. Now, before we can go any further, we have to notice this kilometers. If you put the wrong units into a formula, you're going to get the wrong answer. The formulas only work with the official units. Since kilometers is not the official unit, we have to times it by 1,000 to get 1500 meters, which is the official unit. Now, we've listed. The next step in LERS after listing is picking the equation. The next step in LERS is to rearrange the equation. We're looking for mass, so we need to get mass on its own by rearranging the other variables. M equals EP divided by GH. So we've listed, written the equation, rearranged. The last 3 steps are substitute in the numbers, solve in the calculator, and find the correct sig-digs. So substituting in, we get M equals EP divided by G is 9.81 and H is 1500. Plugging into our calculator, we get 0.01698946 kilograms. But since my numbers have 3 significant digits, 3 significant digits, and 2 significant digits, my answer is only allowed to have 2 significant digits. So the first 2 significant digits can stay, the rest have to go. The 9 greater than 5 rounds the 6 up, so we get a mass equal to 0.017 kilograms.